All right, so this is our first one that we have. We have f of x is defined by f of x so that 3x plus 2 when x is not equal to 5, and it's 19 when x is equal to 5. All right, what I want y'all to say is, then we're going to say what the limit is. The limit as x approaches 5 of f of x is what? All right, I'm going to give y'all a chance to do this and come back. We'll talk about it. Okay, so discussing this problem. So what we're thinking about is one of these remember, every time it's a piecewise, you do it like this. Now, when x is not 5, well, it's not 5 over here, and it's not 5 over here. Right? So on both of those, it's 3x plus 2. From the right and the left, it's 3x plus 2. Right at 5, it's actually 19. Right in the middle. Okay? So, if we're plugging in for the left-hand side, the limit as x approaches 5 from the left. All right? You get 17. So the limit as x approaches 5 from the left is 17. The limit as x approaches 5 from the right is also 17. So even though it jumps up to 19 at 5, does the limit from the left hand and the right hand exist? Yes. Are they the same? Okay, because it's 3x plus 2 on both sides, because when x is not 5, then it's 3x plus 2. So the only time that it's not that is when it is 5. So anything else is 3x plus 2. If you were to graph this on Desmos, all right, it's going to be 3x plus 2. So it's kind of like that, okay, to every single value up until 5. There's a hole at 5. So these are approaching 17. At 5, it jumps to 19. And then on the right-hand side of 5, it's still 3x plus 2, so it's the same graph over there. So that's all it's saying. Okay? The second thing that you got. So I want y'all to find the limit as x approaches 6 of x squared minus 36 all over x minus 6. All right, so when we do this one, when you plug 6 in, you get 0 over 0 the first time. So you have to factor, cancel, plug back in. So this factors to x plus 6, x minus 6, all over x minus 6. Those cancel. So you plug in again. 6 plus 6 is 12. So the limit is 12. So here's number 3. Limit as x approaches 0, tangent of 4x all over 8x. What did y'all get right here? 1/2. What if I got 4 over 8? Okay, that does simplify to 1/2. So when you have the x in the bottom, you just look at that. Okay, for tangent problems and sine problems. So had this been sine, it would have been the same exact way. Cosine would not work. Okay? Number 4. All right. The limit as x approaches 4 from the left, all right, of 1 over, we got 4 minus x. Try that one out. All right, let's talk about this one. Okay? So obviously if you actually plug in 4 for this one, you get a number over 0, right? I get 1 over 0. So if I go back to my rules, limit cheat sheet, number over 0, it's either going to go to positive or negative infinity. Okay, so I've got to figure out which one it is. So 4 from the left, think about where 4 is. What's the number on the left-hand side of 4? Over here, right? So I could try 3.99, 999, whatever. All right, so if I do 1 over 4 minus 3.99, am I going to have a positive or negative in the bottom?
Positive.
So I got a positive over a positive, so this should go to positive or negative infinity.
Positive. So the limit is positive.
Positive infinity. Okay, here's number 5. The limit as x approaches negative infinity, all right, of this big polynomial here, scary guy, 3x squared plus 10x minus 9, all right, over 6x to the third plus x plus 10. All right, so right here, we've got bottom heavy, right? So it's bottom heavy. When it's heavier in the bottom, you're going to have 1 over something big. Okay, 1 over something big. If you take 1 and divide it by 1,000,000, isn't everybody going to have a little small piece? Yeah. All right, so this is going to approach 0. So we say the limit for the bottom heavy ones are going to be approaching 0. Okay, at positive or negative infinity. Okay, number 6. All right, let's look at this one. The limit as x approaches infinity of 7 times the sine of x. Okay, so the sine graph goes like this, correct? As I approach infinity, do I approach one value? No. So this is D and E. Okay? So, right here, let's look at another type of problem. All right, let me look at 7. So here's a limit as x approaches infinity. All right, and we got 5x squared plus x minus 10 all over negative 3x squared plus 2x minus 1. Try this one on your own. All right, so what do y'all notice about this one?
They go square.
So they both have a square. They have powers that are even. All right, balanced powers. So the magnitude of them is the same. So all I really have to focus on is the coefficients of those powers. So what is this limit going to go to? Negative 5 over 3. Very good.
Good job, guys.
Okay, look at number 8. All right, 8. This is going to be a table. Okay. Yeah, so here's x, here's f of x. All right, and in our table, we are going to try to see what x is approaching and what our limit is actually approaching on this type of thing. So 0.01, 0.001, 0.0001. Okay, and our x values are going 1.9, 1.99, 1.999, 1.99999. Okay. So the question I got to ask is, what is x approaching? 2. So the limit as x approaches 2, is it just 2? Is it from the right hand and the left hand?
No.
Where am I approaching 2 from? The left. 1.99 is on the left hand side. So I'll put that little minus next to 2. And what is the limit as x approaches 2 from the left of my graph? It's going to 0 because these are getting closer and closer and closer and closer and closer to 0 as we go. Okay? So that's going to be going closer and closer and closer to 0. Can I go to the next slide? Okay. What am I on, 11?
9.
Oh, my bad. All right. I'm on 9. Okay, let's think about this. So limit as x approaches infinity of 7x to the third plus 5x all over 2x squared plus 7x. All right, so I hear a lot of y'all saying that it is top heavy. Okay, you are correct about that. So think about when it's top heavy, you really have like really the only thing that matters is it's x to the third over x squared, right? Which really simplifies to x over 1. So you have something really, really big because infinity is big in the top. If I plug in positive infinity up here, what's my thing going to go to? Yeah, positive infinity. Because you got a positive over 1. All right, so this limit is going to go to positive infinity.
So always a positive.
All right, it could go to negative. So what would make it go to negative? Okay.
Or odd.
Think about if I had limit as x goes to negative infinity of 7x to the third over 2x squared. Okay? Think about that. And think about if I plugged in negative infinity. Wouldn't this be negative on top and a positive on the bottom? Negative, really, really big number plugging in. All right? Because negative times a negative to the q power, it's a negative. So this one would go to negative infinity. So it just depends on what what I'm approaching and sometimes the signs of the stuff. All right, let's look at 10. All right, so we're going to look at a piecewise function. So let f of x equal this. We got x squared plus 6 when x is less than or equal to 1. Okay, and then we're going to say that it's 2x plus 1 when x is greater than 1. So we're trying to figure out if the limit as x approaches 1 of f of x exists and what it is. All right, so piecewise, okay, draw your dividing point, which is 1. The left-hand side of 1, what is it going to go to? X squared plus 6. So you plug 1 in there, 1 squared, you get 7 is its limit. Okay, so the limit from the left is 7. The limit from the right is 2x plus 1, and that limit goes to 3. So the limit from the left-hand side does not equal the limit from the right-hand side. Therefore, the limit does not exist. Okay? Now, we had a request for one that has 3 in it. Okay? So 3 pieces in the piecewise function. All right? So, let's try to do that here. So I'm going to let f of x be 3 different things. Okay, I'm going to have 2x minus 1 when x is less than 1. Okay, I'm going to say that it is 5 when x is equal to 1. All right, and then I'm going to say that it is let's see. Right? All right. It's 3x minus 2 when x is greater than 1. Okay? So if I want to know, does the limit exist as x approaches 1? So the question I need to answer is, does the limit from the left match the limit from the right?
Yes.
Okay, it does. So y'all did this. I'm going to save y'all some time. Right, 2x minus 1, 3x minus 2. Y'all got 1 on both sides. Okay, y'all did great with that. Now, the confusing part is that at 1 it actually goes up to 5. So why does the limit equal 1 here? Why is the limit equal to 1? Shaheem?
Because it'll be a blank dot.
Yeah, so the graph, okay, at 1 has some kind of hole, right? So it's got a hole in there. Whatever, curvy thing, whatever it is, all right? And then there's a hole up here, but 5, there's a hole that fills in the hole. So it's not continuous, all right? It's got some discontinuity at 1, okay, because it jumps. So it's got some it's discontinuity right there. All right? Yes. Okay. Step is when it actually like jumps a whole step and then goes. Okay? Now let's look at, I'm only going to do a couple more. All right? This will be probably my last one. All right. So, I know y'all probably get a little scared when you see cosines. Okay? But remember, the golden rule of limits is to plug in. Okay, so I'm going to plug in first, no matter what. Try to plug in and see what happens. You got to remember your unit circle right here. Go back to your unit circle. All right, so remember, Coach Metcalf made up this cheesy thing. All right, because y'all know the unit circle. Right? Okay, so this is 1, 0. All right, what'd y'all say?
Cuss your cousin.
Cuss your ex. Isn't that what y'all said? Cuss your ex.
Why sin?
So cosine goes with x.
Somebody said cousin.
And then if you sin, why? Why are you going to do that? All right, so sine goes with y. Okay, so if I'm plugging in 0, I'm trying to plug in 0. 2 cosine of 0. I'm going to my stupid rule that I made up. All right. Okay. So what's the cosine of 0?
I don't know. 0.
What's the x? Are you cussing your x, right? What's the x value at 0? 1. So the cosine of 0 is 1. So this is 2 times 1 minus 1 all over. This is the cosine of 0 in the bottom, right? So that's 1. So what does this end up going to be?
1 over 1. So
2
1.
minus 1 over 1, which is 1 over 1, which is 1. So that limit, all that limit just goes to 1.
Okay.